Could you introduce yourself to the audience briefly?
Yes, so I'm Hebert, and basically I'm known in the Erlang community for having written Learning from Erlang for Great Good. And then after that, I kept encroaching myself in the community by doing more stuff, open source libraries, tooling, and everything. And now I'm pretty much going to the conferences I can, and I think people know me pretty well in these areas. But here, this is Code Mesh, and so it's nice to see a bunch of new faces and get into a wider environment as well.
Could you briefly explain to the audience what you talked about at Code Mesh?
Yes, so mostly my talk is titled Everything is Terrible, and that's the entire theme of it, is that even though you might have a very, very simple application, no matter how confident you feel about it, there's always a slight misunderstanding in how we model the world internally to build on it that is slightly wrong, and that causes all kinds of issues that can be having far and wide-ranging repercussions. And so that's probably part of the philosophy that brings me to Erlang at the same time, even though the talk is language agnostic, which is how can you, you cannot avoid all these kinds of failures, so the logical conclusion is you have to cope with failure happening sooner or later.
Sure. So when people come to me and they ask me, how should I learn Erlang, I usually recommend your book, I recommend Joe Armstrong's book. Do you have any papers that you would recommend, papers or books that you would recommend beyond those two books?
Yes, Jim Gray's paper, I think it's 1986, Why Computers Stops, and Why Computers Stop and What Can We Do About It, which is not about Erlang at all. It's about hardware solutions to computers, but the philosophy that's in that paper is pretty much the entire thing that guides you to the right decisions that Erlang makes. And yeah, so if people want me to know what gives you the best way to think about Erlang, it's a paper that is not about the language.
Yeah.
It's about the same underlying principles. So
that particular paper is one of my favorites. I think it's really interesting because Jim Gray worked for Tandem Computer at the time, which had the non-stop computer. It was basically
Yes.
two computers crammed into one housing, and well, it was software failures was the ultimate cause of why computers stopped. Is that accurate?
They had good protections against software failures at the same point by just replicating things that were happening. Most of the failures that they had turned out to be, well, a bunch of them at the time was hardware, because hardware was far less reliable than it is today. But one of the shining examples that they brought in there is that the two biggest causes of outages they had in production were due to not deploying patches for buggy software, and then the other greatest cause was deploying patches for buggy software itself. And so still, again, everything is terrible. They kind of give you the idea that you don't deploy a patch that doesn't hurt you right now, or for a problem that doesn't hurt you, because any modification is kind of risky.
Sure.
And one of the things that this paper kind of mentions is that operators are entire part of the system. And that brings me to the other papers or possibly talks that I would recommend for that, which is from Richard C. Cook, I think. And he's a researcher who worked with the healthcare industry in terms of how you make reliable systems that go well. And the approach that he recommends tightly integrates really the practice of operating the system into its overall quality and lifetime. And Erlang is one of these interesting languages where runtime operation and the ability to observe a system is baked into the platform, as opposed to something you have to write hooks by yourself into every program you write.
Yeah, I think having worked on large-scale production Erlang systems, I think what's unique to me, and I wonder about your thoughts about this, I think what I found that's unique for Erlang systems is the engineers that build it tend to also be the operators of it. There seems to be less of a distinction there. Is that your experience?
Yes, for a simple reason. I think that it's hard to find system administrators or operators that also know Erlang.
Fair point.
Usually if you work at a company, you're possibly entering it into the company by a small product, and everybody is like, if you want to put that in production, you take care for it. Erlang people tend to be willing to do that.
Yeah.
But overall, I think it's a good practice. I've worked in companies before where the people deploying and running the software are not those who write it. And you tend to have that kind of attitude where you just throw the software over the fence, and there's a very difficult time communicating between the two realities of them, of both teams, to ensure that software you write is easy to operate and run into production. And having at least one person on the team that's able to do both responsibilities, I think, increases the health of a running system over time tremendously.
Yeah, it establishes sort of a positive feedback cycle.
Yeah.
Where you understand the consequence of your actions.
Yes, yes, and your family feels it as well because you're on a pager rotation. And, yeah. That's the downside of it. You don't like that, but if you care about the software's quality, maybe not sleeping all night is kind of it's kind of crappy, but
yeah, they're
hopefully there's a better way in the future, but I don't know. Or there's a better way already. I just worked for people who didn't know how to organize that, and I didn't either.
I don't know of any better way either. I mean, the ways that do seem to be better or less defective are significantly more expensive.
Yeah.
Which, I think in both of the domains that we work in, people aren't willing to pay $100,000 per line of code.
No. If it were possible, I think Code Golf would be a lot more interesting.
It would be.
Yeah. Bigger rewards.
Yeah.
Yeah.
So of the talks that you've seen at the conference, have there been any standout ones to you?
I mean, this conference right now has had some very interesting big names speaking. Guy Seal has given in the past one of my favorite talks of all time, which is Growing a Language. Mm-hmm. And he gave one where he just went through the kind of notation that programming language researchers use when describing their own programming language and making the history of that. That one I found to be extremely interesting, but there's just a lot of big names who know a lot more than I do. And it's fairly interesting for me to get into that kind of aspect with really being in the same room as the big names around.
Yeah. So I'm actually not familiar with Growing a Language. Can you?
Basically, it's the approach of, I would say, the scheme or list philosophy, where Geisel just starts the talk by assuming that all words with 3 or 4 letters are known by the audience, and every other word introduced in the talk, he has to explain and define them.
Okay.
And as he goes, you just build that entire language with all the terms required to make complete sentences that are easy to understand for everyone. And it kind of shows that idea that what you need is the extensibility to create your own language and expand it.
Interesting.
Yeah, it's a great talk, if only for the execution of it.
Yeah. That sounds tidy. Well, I don't think I have any more questions.
All right.
Thank you very much.
All right. Thanks for having me.
Yeah.